Hey guys, welcome back. Today I'm gonna present a new sensor, a new digital sensor that is BMG160. To have a more knowledge, a more insight for this sensor, let's have a look over the website that is controleverything.com, and here we have to search for this sensor that is BMG160. Now let's see what we got for this sensor. So this is a 16-bit triaxial gyroscope sensor, and the range, as you can see, from 125 to plus minus 2000 degrees per second. Now these are some of its more features, and you can also add to cart or you can purchase this sensor from this very site. Now I'm going to interface the sensor BMG160 with a particle photon, and for that I require a particle code. And so let's have a look over particle code, and we can download the code sample as zip file from this very site, as you can see from here. And we can have also the code from GitHub repository that is Control Everything Community. Now let's have a look over the hardware we require for this particular sensor and to make it working, and let's see. Now this here is our sensor, that is gyroscope sensor 16-bit BMG160. Now this here is a particle photon. Now to make a connection among the particle photon and the sensor, we need an I2C shield, which is available on the controleverything.com. Now this reason why we use this shield is to make connections with other I2C devices connection a lot easier. So gently place the particle photon over the I2C shield and make this connection. Now we need connection among the sensor and the I2C shield, of course, with the particle photon. So this connecting cable comes into the picture. Make the connection among the sensor and the cable, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to do this with I2C shield. Now last thing we need is to power up our particle photon, and we need a micro USB cable just like this, and gently put it over or insert it over the power jack. Now the connections are being completed. Now what we need is a particle code. Let's have a look over that. Now as we are moving forward, we need a particle code so that we can have the interfacing of the sensor with the particle photon, and for that github.com comes into rescue, and here we have our repository that is Control Everything Community, as you can see. Now here type in the sensor name BMG160, and here it comes. Now this is the particle code we are going to explore, but before that let's have a look over the instructions for the particle photon. We have to log into our particle photon and set up the device, and this is the link which will help us to guide through that. Now to download our code, and after that we have to copy this entire code on the online ID, and build.particle.io will help us to build that particle and all the relative information of that. Just like copy the code and go to the online ID. After that, the last step is to verify and flash the code on the photon. When we flash that, we have been generated a output, and that output can be displayed on the dashboard, and this is the link for that. You can have a look over that. Now we are done with the instructions. Let's have a look over the particle code again, and it's a .ini extension file, as you can notice. First of all, we have included the required libraries of like application.h and spark wiring I2C.h. These have some functionalities which might be used later in this code, and we have the definition of define the address of the sensor, that is 0x68. We have initialized some factors here, variables here, and also like here. Now we need to initialize I2C communication as master and initialized serial communication with the baud rate equal to 9600, as you can see. Now this comes to the writing part. Here we have selected the range register, that is 0x0f, and here we have configured FSR, that is full scale range, that is plus minus 2000 degrees per second, and the writing command is 0x80. In the second part of the writing section, we have selected bandwidth register, that is 0x10, and we have the bandwidth equal to 200 Hz, and that is 0x04. As we are done with the writing part, we are proceeding further. So we have void loop function where we have selection of the data register 0x02. From this very register, we have requested 6 bytes of gyroscopic data, which comprises of x, y, and z axis, as you can see. Now the data is being compiled here, reading is done continuously, and we have our values stored. Now these values here, all the gyroscopic values for x, y and z axis are being converted using the relevant information provided in the datasheet for PMG160. So we are done with the calculations part. Now we want to display the results on the screen. So for that we have the output data on the dashboard, which is in the form of x-axis, y and z-axis of rotation. Gyroscopic data is there, and we have formatted according to the raw values. So as we are done with this generalized and simple code, and you can have a look over yourself, as you can notice. Now we want to do the working, which is very interesting for that. Now here comes the interesting part, which is to show the practicality of this code. So for that, copy this entire code, open on the build link we have discussed earlier in this video. Here we have to create a new file, paste the code we have just copied. Yeah, PMG160 is the sensor name, and paste the code and save the firmware. Now verify and compile the code. Now we have to flash. Now while flashing we have to check for the magenta flash, and successfully we have that, and the notification you can see on the downside of this screen. Now what do we require is to open up the dashboard link so that we can have the output to be displayed on the screen. And here we go, we have the rotational x, y, z axis values which are perpendicular axis to each other. They are almost stable as we can see. Now when I try to rotate the sensor, you can see the changes in the values regarding the three perpendicular axis and in the rotational values for x, y and z axis. So as I try to rotate, the changes will be reflected on the screen in the form of rotational x, y and z axis. So this is how the sensor works along with the code. Now what we require is to see the features, the benefits and the reason why we use this sensor into a lot of applications. So just now we have seen the working of the sensor BMG160, the codes and explanation and a lot more for this sensor. The BMG160 is a 3-axis angular rate sensor that is made up of a surface micro machine sensing element and an evaluation ASIC. The BMG160 is designed to meet requirements for consumer applications such as image stabilization, that is DSC and camera phone, gaming, image stabilization, gesture recognition and pointing devices. It is capable to measure angular rates in 3 perpendicular room dimensions, the x, y and z axis, and to provide the corresponding output signals. Now this sensor is available and can be purchased from this very site, that is controleverything.com, and you can have the code from the resource tab, and after that you can download it. Now you can have also the code from github.com, and the repository there is Control Everything Community. Now as I just want to make sure that in case if you want to understand any part of this video or any issue, you can check me or you put your queries on controleverything.com, and you can post any comments on the community page of this website. Now for articles and blog like this, you can check me on instructables.com, and to pursue more videos like this, you can subscribe our YouTube channel. I hope you are doing well and you like this video, and have a good one of yourself. Thanks a lot for the watching. Goodbye.